Hello, and welcome to today's special event, Scaling for Growth Using Data Analytics, brought to you by Spiceworks, Ziff Davis, and Looker. I am Karen Bannon, and I will be your moderator for today. I have just a few quick notes about our console. Slides will advance automatically throughout our event. In addition, the console you're looking at is customizable. This means you can move and resize any of the windows you see open, as well as explore the widgets at the bottom of your screen. For instance, you'll find handouts and links right there in the interface, as well as a link that you can use to request a personalized demo. We'd like the event to be as interactive as possible, so at this time we invite you to ask any questions you may have using that question widget, which is located below the slide presentation window. We'll get to as many of your questions as we can towards the end of the event. And finally, an on-demand presentation will be available after our event. So if you can't stick around for the entire time or just want to share it with a colleague, you will receive a link via email. So fast-growing organizations are under constant pressure to deliver quality products and services while maintaining maximum internal efficiency. Using data analytics can help you find ways to reduce production and operational costs, as well as improve your bottom line. Analytics can also help you uncover new marketing and advertising avenues and build better products, features, and services that people want to buy. This is why during today's webinar, our expert speaker will discuss how companies such as GoCardless, PopSockets, and Salesloft are using data analytics to identify new opportunities, markets, and market trends to fuel business growth. They're also saving time and money, as well as powering data experiences beyond basic reports and dashboards. Our speaker will also give us a demo so you can actually see Looker in action. And so with that, I'd like to introduce our expert, Scott Barber. Scott is a senior professional services consultant for Looker. In his role, Scott is charged with providing leadership and technical advisement to Google Cloud and Looker's strategic enterprise customers. His work includes facilitating the requirements gathering process and designing embedded applications, performing hands-on development of data models, reports, and dashboards from inception through production stage, advising on key metrics, technical and business processes, and helping customers rethink the approach and efficacy of certain KPIs in order to drive the successful adoption of and end user satisfaction with Looker. And with that, let's get started. Scott, I'd like to turn the presentation over to you.
Thank you, Karen. Welcome, everybody. I'm very pleased to spend some time today with you. And my goal today is to just give you a taste of some different analytical methodologies that you can use to dig a bit deeper as you grow as a business. So what we're going to cover are really three analytical patterns. We've got three big objectives. The first thing we're going to do is talk a little bit about lifetime fax analysis. That is, trying to understand the behavior potentially of customers or customer service agents over time, so that we're not looking just at a stream of live data, but we're actually taking a look at behaviors over the entire lifetime of a set of people in our organization or a set of customers that we have. And we're going to sort of take the same repeated pattern across all of these. We're going to talk a little bit about why would you do this kind of analysis. Then we'll dig into the high-level overview of specifically how you can do this. We'll then launch into a quick overview of what this looks like, and I'll actually live demo the scenarios for you. So in addition to lifetime fax analysis, we'll talk a little bit about best period comparison. That is, how do we compare, for example, sales this month or call volume this month to our best or worst, depending on your point of view, period in our history. And then finally, we'll finish our time together with a review of retention analysis. As an organization grows, oftentimes they're looking to pivot from acquisition to retention. And so we'll enable you with some tools that you can use to actually go through and trying to understand the degree to which you're successful at retaining customers and trying to understand the patterns of behavior as a customer of yours or as maybe a call agent achieves tenure over the course of their lifetime. So let's jump in and continue. We'll have a combination of a few slides, and then we'll jump out into some demo activities. And I would encourage you to leverage that question and answer section to ask any questions that you may have as we go along, and we'll try and reserve some time at the end to go through them. All right, so let's jump into lifetime fax analysis. Right? So why would we do this kind of analysis, right? So if you're a sales or an e-commerce organization, for example, you might be trying to understand, well, which customers or products are generating the most revenue over time? If you're a marketing organization, you might be trying to compare recent campaign results against cumulative results. Or if you're in an account management or customer support organization, you might be trying to answer the question, well, is an individual agent's call volumes above or below their historic norm? And so to do these sorts of analyses, there's really a handful of steps that we need to take. In the context of Looker, step one is that you would need to generate a base query. That is, we need to go out and create a primary key and then get all of our relevant measures that we want to track over the lifetime for our users or our call agents and so on and so forth. We'll then create what's called a derived table with derived columns and some measures. For those of you who've got some SQL experience, this will create something called a common table expression behind the scenes. And what we're going to do is we're going to add in some things like ranks and averages so that we can dive a bit deeper into the way that our customers are behaving. We'll then join this into something called an explorer in the Looker context, which will give us an ability to take, for example, our customer data and marry it to this customer lifetime behavior data. And then finally, we'll create an effective visualization. So looking at something like average lifetime spend by state or average order size by zip code. So what we'll end up with is, in this particular example, we're going to try and generate a heat map. That is, now I'd like to know where in the United States are my top customers in terms of let's say, a global top 500 by revenue. Now, the challenge that I'm up against is that I have this global top 500, right? And that is not filtered by location. And we use that global top 500, for example, to identify our biggest, most lucrative customers. But I'd like to understand, of those global top 500, where do the ones in the United States live so that I could perhaps tailor a marketing program regionally towards that audience as I grow. So what we're going to do is walk through a step-by-step demo. That is, where do our U.S. customers live that are in the global top 500 in total sales? So with that, I'm going to just jump over and spin up a quick demo of my Looker environment. And so bear with me for just a second while I bring up my window here. And so what I'm sharing on my screen right now is a basic explorer in Looker that gives me details on the orders that have been placed for a mythical e-commerce company. And in this particular case, this is a small firm that is growing, and their primary business is selling fashion and fashion accessories, right? So clothing, belts, so on and so forth. And what I have done is gone in and created a table here of all of the different characteristics of my users that I'd like to understand more about. So for example, I've pulled in a user ID. So this is a unique identifier that tells me who each person is that is a customer. I've then added in a field for total sales, the earliest order placed by this person, the most recent order, and then a couple of things that are also related to their lifetime purchasing patterns, right? A count of how many orders they've placed, and a count of order items. That is, if their first order they ordered 5 things and their second order they only ordered 1 thing, that would give them 6 total order items. And so what I'm going to do with this is actually create what's called a derived table. That is, what I want to be able to do is look over the entire lifetime of all of the users that I have. And I want to be able to match this data back to them so that I can learn more about, well, where do these users live, what kind of products do they buy, and so on and so forth. So what I'm going to do once I've created this basic table is that I'm going to go up to this little gear icon, and there's an option here for Get LookML. And we see there's an option for Dashboard, Aggregate Table, and Derived Table, which is what I was discussing earlier. Now what I would do is take and copy and paste this little snippet of code. Now, if you're a LookML developer, or if you've got some experience developing in LookML, which is our Looker modeling language, this should seem relatively familiar to you. If you're just a business user of Looker or somebody who's trying to understand Looker's utilization a little better, then you're going to have a Looker developer in your organization who knows how to manipulate this sort of thing. So what I would do is copy this code for a derived table and then change it around a little bit. Now, like any good television chef, I've already got a pre-baked version of this cake. So what I'm going to do is just switch over into my Looker data model. And what I've done here is created a derived table called user facts. And that comes directly from this little snippet of code that Looker generated for me. And so I'm seeing that I have a table that is coming from my order items Explorer. And it has columns for ID, total sales, our earliest order, our most recent order, and it gives me a count of orders over lifetime. Now, what I've done here is I've actually added 3 different what are called derived columns. The first thing I'm adding is a revenue rank. That is, this tells me where does this particular person rank in terms of their total lifetime spend with my company. And in this case, we're going to rank them by total sales. I also have an order rank. That is, let's rank you by the number of orders that you've placed. Are you the person who's placed the most orders, or the second most orders, or the third most, and so on and so forth. And then finally, I'm going to create a column for average order value. That is, I'm going to take that person's total sales over time, and I'm going to divide it by their count of orders. We're not going to use all of these derived columns, but the whole idea here is that these derived columns use what are called window functions in SQL. And so I have a need to add them in as separate columns that I calculate. And what Looker is going to do is actually write me the SQL functions needed in order to calculate a ranking of where you are revenue-wise and a ranking of where you are order-wise. I've also gone in and added a few additional dimensions that allow me to understand better the total sales and added some labels so that these things can be consumed by my business users. Right, so we're not going to go into every single element of the underlying LookML, but I do want to show you then what this winds up looking like inside of Looker itself. So what I am now going to do is go to my I'm going to go directly to my user facts, or my users Explorer here. And you'll see that I've got areas for user facts, which contains all of these now lifetime user facts that I've just calculated as part of my derived table. And what I am going to now do is I'm going to, under users, select map location. Right, so what this is going to do is tell me where these folks live on a map of the globe. And then I'm going to select total lifetime sales. Right, this will then show me by location where are most of the sales happening. I'm then going to do a little bit of additional filtering, right? So what I need to do is, if you recall, we were interested in 2 things. We were interested in whether this person was in the top 500 customers globally by sales. So if I go to lifetime sales rank and I filter, I can say that this is less than or equal to 500. And then the other thing that I wanted to know was, I wanted to only look at customers that were in the United States. So I could go to country and filter on it and say that our country is equal to USA. In doing so, I can go ahead and click run. And what Looker is going and doing right now is going out and actually querying my database directly. It is now returning me a series of map locations, and it's giving me a total lifetime sales for that particular location on the map for all of the users that happen to live in that geographic area. If I go to visualization, Looker has detected that I'm interested in a map. And now what we see here is a map of the United States. What it shows you are all these little dots associated with where all of our customers live. But I don't have really any sense for where the big customers are versus where the smaller customers are. So if I go to the edit menu here, I can choose an automagic heat map. This is a clever name for a form of a map that what Looker is doing now is sort of aggregating the data by geographic region based on the scale of my map. So here I see that I've got the whole of the United States, including Hawaii and Alaska. And I now see that I've got a segment highlighted in red. Right? This segment highlighted in red indicates that in this segment of the map, we have an aggregate total lifetime sales of $43,741. Whereas I can compare that to, and that looks like it's somewhere on the East Coast, maybe in the New York, New Jersey region. And then if I look maybe at my next highest area for total sales, it looks like something maybe in Chicago at 31,000 or 32,000, and then somewhere maybe in the San Francisco Bay Area where I have about $26,000 in total lifetime sales. So through this analysis, I've now given myself a way of understanding where roughly those lifetime sales, those lucrative customers are living. And I can even do things like double-click in on a region, which will cause Looker to recalculate and replot my map. And I now get even more granular detail where I see, it looks like these users are really clustered in and around New York City. And in this small geographic region, out of that 41,000 I talked about earlier, we see that we have about 35,000 concentrated in this small red square. So we can return to this at the end if anybody has any questions, but that is an overview of how to calculate a total lifetime value for individual customers. All right, so let's return to our slides. And now let's talk about doing a best period comparison. So in a best period comparison, what we're trying to do is try and understand, like, how does today's or this week's or months or quarters sales compares to the best day, week, or month we've ever had. Or perhaps from a marketing perspective, you're trying to understand for a particular marketing campaign, how does this week's results compare to the best week we've ever had with this particular campaign or with any campaign for that matter? Or maybe if you run a call center, you're trying to understand how call volume today so far compares to our heaviest or lightest day in our history. So in terms of how we might tackle this type of problem in Looker, the first thing you're going to do is generate your best period query. That is, you're going to try and understand your comparison period. Do you want a day, a week, a month, a quarter, or a year? And then add in the measures or metrics that you care about for that particular period. We're then going to create a derived table and add some sort fields and some limits so that we can filter only on that best week that we're talking about. We'll then add in some filter fields so that you can find just the weeks that match either your current period or your best period. And then finally, we'll visualize the result. What you should then end up with is something that looks sort of like one of these two visualizations. On the left, we have an example where we're looking at results month to date, but we're also able to see how the rest of the month has gone for our best month ever. And then on the right-hand example, we've actually modified the graph to only show month to date for both the current period as well as our best period ever. So let's dive into an example of how we're going to do this. So our guiding question here is, how does revenue compare month to date to my best month ever? So here again, we're going to go ahead and jump into our Looker demo environment. And what I am going to do here is we're going to go ahead and look not at our Users Explorer, but this time we want to look at our Order Items Explorer, because this one is the one that tells us about the orders and the items in those orders and how much sales and revenue have resulted from those orders. So if I go into Order Items and I open up here, I see that I've got an area to explore the date of the order as well as total sales for that date. So in this particular case, we're trying to compare revenue month to date for my best month ever. So what I'd like to do is figure out, well, what is that best month? So what we're going to do in here is we're going to go into Dimensions and we'll go to Created Date, right? This is when our order was created. And we're going to choose month as our date dimension. And then we'll also add in the field for total sales. This will help us understand total sales for each month. And what we're going to do is click on the header here for total sales and sort this descending. And then we'll apply a row limit of 1, which will give us only the week with the most sales, or the month with the most sales. So we'll go ahead and run this, and we see that we get a result back of April 2020 as being the month that had the greatest total sales, right? So we'd love to know, well, how are we doing so far in June, and how does that compare to April? Are we ahead of April, or are we a bit behind April? Right. So what we're going to do is create again a derived table from this particular query, because this is the query that tells us what month is our best month. So we're going to click on Get Look ML, and we're going to go, once again, go to Derived Table. And I would copy and paste this Derived Table code into my data model. Now, again, as I noted, I've already got some pre-built versions of these. So I'm going to go into my views, and I'll go to Best Sales Month. And you'll see here that I've created a view that it looks very similar, but I've added a few extra things to the mix. The first thing I've added is a filter, right, that says before 0 months ago. If it turns out that the current month is our best month ever, I don't want my graph to immediately change so that my current month and best month are identical to one another. I only want a month to become a best month after it's passed into history. So what I'm going to do is add a filter here to this Derived Table that says that our created date is before 0 months ago. What this little filter expression tells us is don't include the current month in this historic data, only include past months. The next thing I'm going to do is add a sort parameter here. So we're going to sort on total sales descending. That is that we're going to sort this from top to bottom so that our first result returned is going to be the result with the total, or sorry, with the highest amount of sales. We'll add a limit of 1, which means that we're going to limit the results to a single row. And then lastly, we're going to add a parameter for time zone, which says we're going to align the time zone for this, this derived table with the time zone that my query is being run in. This way, let's say you're a multi-location organization where you've got branches in Central or branches in the West, and they're spread across different time zones. This will ensure that whatever time zone you're using to query the data, that's the time zone from which month would be calculated. Otherwise, you run the risk of your month and a month in another part of the country may not be exactly the same. We then in turn added a couple of additional dimensions and filters. One dimension is uses an expression that tells us whether or not this is our best month ever. So what we're going to do is compare our created month, that is when the order came in, with whether that created month is the same one in this table that we just created. And then we're going to add a filter that tells us whether the month is our current month or our best month ever. So with that in mind, what we're going to do is jump back in to our Explorer for order items. And we're going to go ahead and clear everything out. And this time, what I'd like to do is understand our sales on a monthly basis. And I'm going to look at total sales for that month. I also want to know the day of the month. That is this the first day, the second day, the third day, and so on and so forth. So what I'm going to do here is actually pivot on created month. I need to then additionally add a few extra filters. So under my best sales month header here, I have this header for is best or current month. And I'm going to filter on that and say, is best or current month? Yes. This should restrict my results to only the best month that we've ever had and the current month. And I'm going to go ahead and click Run. So now what we see is that we've got a number of different columns here. I'm going to just do a little bit of cleanup. I'll sort by my day of month so that that day of month is sorted from the 1st all the way up to the 31st. You'll also see here that my best month was in 2020-04, so April of 2020, and the current month is June of 2020. But Looker automatically pads the missing dates here, and so I see I've got a column for May with no data. What I'm going to do is go to this gear icon and just say, remove the filled in dates. I'll rerun this now without those filled in dates. And now what we see is for on day 1, we have sales on the first day versus sales on the first day in June, sales on the second day versus sales on the second day in June. I'm going to do one more thing in order to make this a more effective analysis. I'm going to create a running total. And so what I'll do is go to my custom fields area, I'll click new, and I'm going to add a table calculation. And we'll call this table calculation running total of sales. And there is a table calculation called running total. and we're going to refer the running total to our total sales. Right, so, and we're going to add in a formatting in US dollars with 2 decimal places for cents. So I'll then click Save. And now what we have in this final column is a running total of sales. And we see that on day 1, 16,499 versus 16,518. On day 2, 31,466 versus 32,808. So if I now look at how this is visualized, I see I've got some lines here. And what I want to do is hide the total sales from my visualization. And what I get now is a line graph that shows me the pathway of this line for the current month, or for the best month ever, and then the pathway of this line for the current month. Now we see that this plateaus, right, because these days are in the future. They haven't happened yet. And so what I am going to further do is add in the option here to restrict this to month to date. Right? This extra filter that I've created says, well, we're only going to look up to the current date on the calendar, right, which is going to be the 11th. So now I can click Run. And what I now have is a chart. Once again, I need to go and remove our filled in dates just so that Looker doesn't go and populate all those missing days for us. And now what we have is the sales results for the first 10 days of the month. Now this visualization is not super effective at helping us understand the difference in our progress. So I'm going to just change this ever so slightly. We're going to go in and customize this. We'll go into series here. I'll scroll down. And what we're going to do is make that best month ever, or sorry, make our current, our best month ever, yes, a column. And now what we can clearly see from this visualization is that we are tracking ever so slightly behind our best month ever, right? So we're not quite where we need it to be. Now, we can even make this a little bit clearer by changing our series to make a filled point style. Right? And now what we see in this diagram is that actually up until today, we were generally tracking ahead, up until yesterday, we were generally tracking ahead of sales for our best month ever. So June was on track to be the best month in our history. But now, as of yesterday, we've actually started to fall a little bit behind the curve. Right? So then that might lead me to try and understand, well, what happened yesterday that was different than the 10th day of our best month ever? You know, maybe it turns out that it's just a difference in day of week, where the 10th this month was a Saturday, and that's not a big purchasing day, whereas the 10th last in our best month was a Monday. You know, there are ways that we can look at this, of course, differently. But hopefully this gives you an overview of the type of analysis that you can do that allows you to compare your month to date to your best month ever. One of the things that's nice about this is that by setting this filter this way, if you added this visualization to a dashboard, then tomorrow when this same visualization is run, it will incorporate another day's worth of data automatically. So you don't have to come in here and change any dates manually. Instead, Looker will automatically calculate that, oh, you know, there's a new day in the month that is passed, and automatically incorporate that data, assuming it's available into your visualization. So with that, we'll go ahead and jump back to our slides and then finish up with our last example. So now we're going to talk a little bit about retention analysis, right? So, you know, why retention analysis? Well, as a growing company that is going from your nascent stages of your growth to actually getting into the time in your development that's really going to determine whether you become wildly successful or whether you maybe plateau or whether you start to fall off over time, is really shifting from acquiring customers to how well you're retaining those customers, or from a marketing perspective, you know, trying to understand, well, what marketing channels are most effective for driving retention. But retention analysis isn't just for sales and marketing. For example, in an account management or support environment, you might want to know, well, what issue types are leading to the most repeat callers or the most ongoing support requests. So what we can do in order to do this is that the first is what we would need to do is create a SQL query that calculates our key metrics per month per user. I want to highlight here that what we're going to need to do in this particular case is use what's called a padding join. The idea behind the padding join is that you want to be able to calculate zero values even for users that might not have been active for a given month, right? So let's say a user purchases this month, they don't purchase next month, and then 3 months later they purchase again. Well, what you want is for them to appear in your data set every single month from the time they join, but for the months where they didn't purchase or didn't access your site, you want them to have zeros. You don't want them to just be missing. So we need to create a specialized SQL query that does this for us. We'll then populate that into, again, one of these derived tables. We'll create a purpose-built Explorer that joins this information back to our users view. And then again, finally, we'll visualize our result and look at something like average spend per user by months since they've signed up. And so ultimately what you'll get are graphs that maybe look like these. In the case on the left, we're comparing the average spend per user over how many months that they signed up and trying to understand how many users remain active. In the right-hand example, we're trying to understand, based on marketing channel, how well are we doing on retention? That is, are there certain marketing channels that lead to users that stay retained, that stay purchasers or stay users longer than other channels? Is email more or less effective than Facebook, which is more or less effective than display ads? So again, let's dig into an example, and then we'll have some time for Q&A. So our guiding business question here is, what is our user retention and our monthly spend per active user over the first 12 months for the users who signed up for an account via email? Right? So we're specifically interested in those customers who came in by email and what their behavior looks like over the first 12 months. So let's once again dive into our example Looker environment, and we'll examine this in a bit more detail. So what I'm going to do to start here is really start by building out the SQL query that I need to get this padded data for user behavior. So I've already pre-created this SQL query against my database, right? So Looker has been wired up to connect to my upstream database, and I'm now running a straight SQL query against it. And if we take a look at the results of this SQL query, what it's bringing back to me is that there is an entry for every user ID and it contains their sign-up month. There's then an entry for every month that my company has been in existence and indicates whether or not that person purchased in that month or not, right? So how much did they purchase that month? Like how many purchases did they make? How much did they spend? And then I've also added a key in here, which is just a primary key for the user to ensure that I have a unique value for each row so that all my calculations work properly. Right? Now, again, what I've done is sort of pre-created a recipe style version of this. And so what I have here is a view that creates a derived table using this SQL expression that returns exactly those results. What I've then done is added a few additional measures that are further derived from that SQL table. Things like what percentage of my cohort are still active. That is, if I take my total active, divide it by my total users, then that tells me what percentage of my overall user base remains active. I might want to look at spend per user. That is, how much have users spent in total versus how many total users there are. But I also might want to look at spend per active user. That is, as my number of active users falls off, my spend per user will fall off because I'm including all of these users that aren't active. But I want to know about the users that are still active and what they're still spending. So again, if we kind of go back to this notion of I want to understand user retention, then I'm trying to look at the behavior in terms of when do they stop using the site, when do they stop buying. But then for the ones that are still buying or are still using my site, what are those long-term users doing, and how maybe should I drive behavior to be more like those highly engaged or highly lucrative users. So now that I've created this view, I've actually gone and in my data model created a purpose-built explorer called User Monthly Activity, right? And perhaps this explorer is just available to my marketing personnel. So I'm going to go ahead and jump down and load up this User Monthly Activity Explorer. And this is purpose-built just to help us understand monthly activity ever since a user signed up for our service. So the first thing we're going to grab is this month since sign up, right? So what this field is calculating is how long has it been since this person created an account for our respective service, right? Because we want to know how behavior changes as a user gets away from their sign up date. The next thing we want to know is just what percentage of this cohort is active. That is, for users that sign up in the 1 month from their sign up date, how many of them are still using our site? 2 months from their sign up date, how many of them are still using our site? 3 months, 4 months, and so on. So I'm just going to grab these two things and I'm going to click Run. And what this will do is go out and query my database directly. And now if I sort by months since sign up, I can see, and the visualization is even more effective here, that I can look at, and now let's make this a column chart just to make the visualization a little easier. We see that in month 0, 92.3% of people are actually active, right? So what this means in my particular example here is that when people create an account, 92% of the time within that first month, right, what we'll call month 0, they've actually made a purchase, which is great. But now, if we go to month 1, we see a huge fall off, right? So after the first month, only 27% of those people are still active. Now, I do get a nice little bump in month 2 where they jump up to 31%. But then there's a long sort of tail here where we see, going all the way up to a year, their activity just falls off, right? So if I'm only interested in their first 12 months, what I can do is just further filter this on the months since sign up is less than or equal to 12, because perhaps I'd like to understand just the behavior over their first 12 months. All right, so this is giving me our user retention over a 12-month period. And we see we go from 92.3% of people engaged in that month 0 to only 10% of users being engaged by month 12. Now, this is for everything. This is for all channels, regardless of how a user signed up. Now, let's compare that to their spend per active user. That is, for each of the users that appears in this cohort, how much on average are they spending? So we'll go ahead and run this as well. And I'm just going to make a few minor tweaks to my visualization because we see the scales are kind of blown out a little bit. So I'm going to go to Edit. I'm going to go over to my Y-axis here, and I'm going to drag and put this spend per active user on the right axis instead of the left. This will allow it to have its own independent scale. I'm then going to change this and make one of these a line graph, so that our percent of cohort active, instead of being a column, is actually a line plot. So we get a graph that looks somewhat like this, right? And so the story that this is now telling me is that over time, generally speaking, users that remain engaged and keep ordering aren't really growing their overall orders. In fact, they tend to spend the most in their first month. They fall off pretty quickly, but then they remain stable over the remaining lifetime of their time as customers, at least for this first 12 months. Now, in particular, I was curious about, well, how does this look for somebody who signed up by email versus maybe by some other channel? So I have this field called traffic source that's part of my CRM system and is included in my user data. I'm going to further filter on that. And we're going to look at this traffic source. And we were interested specifically in email. So I'll just go ahead and filter that traffic source by email. And now what we're seeing is we see a similar pattern that emerges, right, where we don't see that email is sort of meaningfully different than my case earlier. I do see that in month 1, I've got a slightly higher activity for people that engage by email, but I still see the same pattern of a little bump in month 2, followed by a further fall off. I could even attack this problem slightly differently let's focus on maybe just that % of active users, right? Because our spend looks pretty flat. So we're going to go ahead and take that spend out. So let's remove the spend per active user. And we'll stick with this % of cohort active, right? We'll rerun this, and we'll get our line graph that we saw earlier. But I'm looking at email. I'd like to understand, well, how does email compare to Facebook or display ads or something else? So I'm now going to remove traffic source as a filter. And instead, I'm going to add it back in as a pivot. So we'll go ahead and pivot. And we'll go back to making this a line graph because I feel like that's ultimately the most effective way to express this. And let's blow up our visualization a little bit. And now what we can see from this is that our least effective in terms of customer retention over a 12-month period is display ads, right? So for display ads, we see 87.2% engagement in that first month, and then that immediately falls off to 16%, recovers ever so slightly, but then tails off pretty dramatically so that we're only at 5% retention by the time we hit 12 months after they signed up. Compare and contrast this in this data set with email, where we see a 3x rate of retention as compared with our worst performing channel with email at 15.5%. And then we can see Facebook doing nearly as well as email in this particular data set with 13.6% retention, followed by search and so on and so forth. Right, so this gives us an idea of how to leverage this sort of padded data to try and understand, well, what's my fall off in terms of user retention, and then how potentially can different marketing channels control this, right? But if we think about this same analysis for call center operations or a customer support organization, this pivot might be based on issue type, right? Are they calling with an IT issue? Are they calling with a website issue? Are they calling with a sales issue? And then that could, in turn, be plotted against percentage of return calls, that is, recalls into the help desk. So what customers that keep coming back to us for more and more support, what are they calling about? And what was their first call, for example, about? Those are the types of analyses that you might be able to do here. So with that, we'll go ahead and pause and open up the floor for any questions that you might have had. What I would just like to do is sort of recap a few key takeaways. You'll use, for lifetime fax analysis, we'll use this to understand total value independent of time. Your best period comparison is used to compare your current period's performance to your best period ever. And then retention analysis is really about trying to understand changes in customer behavior over time. All of these can leverage a Looker feature called Derived Tables and offer you the opportunity to create rich visualizations that are automatically updated and that operate directly on the data that's in your modern data warehouse. And with that, we'll open it up to questions.
Great, thanks so much. A lot of information presented, great presentation and demo. So if you've got any questions about anything that you've seen today, you can go ahead and send us your question right there on that question widget, which is below the screen. It's the middle widget. So I've been watching, though. We've got some really great questions that have already come in. So why don't we jump right in here and start with some questions. So why don't we go with this first question here? So the question is, how would Looker treat a string type variable? For example, a number stored as $12,345.67 as a string value.
Absolutely, that's a good question. So I'm going to jump a little bit into LookML under the hood. The first thing we'll do is I'm just going to go to SQL Runner to show an example of what something like this might look like. So I'm just going to type in a quick query here that's like select, and we'll use the example of 1, 2, 3, 4, 5, 1, 2, comma 3, 4, 5. .67, and this is actually stored as a string, right? So the question is then sort of how do we parse this number or how do we parse the string and convert it back to a number? And so there's a few things that you can do here. Ultimately, what you would want to do in the looker context, right, is come up with a SQL expression that is able to parse the string value, remove any formatting characters from it, such as the comma or the $sign, retain any essential components like a decimal place, and then recast that number as a number like a floating point or like an integer, depending on what you're doing, right? So if let's just say, for example, that I had a field that looked like this. If I went into my looker code and I went to order items, and let's just say for the sake of argument that my sale price field was formatted that way, right? Then what I could do is use something like regex replace, or depending on your dialect, you may use just the replace function. And the idea is that you could do something like replace then the field, and then replace all of our $signs with nulls or with blanks. You could do the same thing for commas. And again, this is highly dialect dependent because some dialects may have built-in functions to handle this conversion for you. And then we would take the result of this and let's say we cast it as a double. Right? And then what Looker would do is every time it accessed the sale price field from your table, it would apply this little blob of SQL to that field and then automatically calculate the right value. Again, certain SQL dialects may be able to do this kind of auto conversion in line or through some sort of built-in function, but this might be a general case way of handling this type of problem. Hopefully that answers the question.
Okay, great, thank you. I'm not sure that your screen shared that during that last
Oh, I'm
answer.
sorry. My apologies. Let me retry that, and we'll replay that really quickly. So let me jump over to my Looker demo environment here.
There we go. Got it.
Excellent. Sorry about that. The perils of live demo. So what I have here is Looker is operating using this curly braces table notation to refer to the table in your database. Right? And what I've done is, if I know that this sale price field is actually a string field and it's got certain formatting around it, what I can do is write just a little SQL expression that extracts the numbers, retains the decimal places, and then recast that value into an appropriately, into a double or into an integer, depending on what you're doing. And then what will happen is every time Looker refers to sale price, it will execute this conversion function against that field anytime, any place that I need to use it.
Okay, well, we have plenty more questions, so let's jump in with the next question. Let's see. So the next question is, so I think the question is, how do you enter the data onto the Looker system? Also, would the Looker system be able to accommodate data tables in .csv and .pdf format?
Absolutely. So Looker is operating against an upstream database, right? So everything that you're seeing here is not operating against like flat files or anything of that nature. What it's doing is operating against a series of data connections, right? So in this particular case, what I'm doing is I'm connecting to an Amazon Redshift database that contains all of this data already pre-populated, right? So I think in response to the question around whether or not you could accommodate a CSV, if we're talking about loading data from a CSV, then absolutely that data can be loaded from a CSV into your target database. Once it's available in your target database, then Looker can operate against it, and we can create a data model against it. Now, it's also possible that the question is related to exporting the items. That is, if we go back and we look at this data table that we've created, perhaps I would like to take this visualization and I would like to save it as or export it as a PDF. right? So what I can do is if I go here to, wrong item. I can save this as what's known as a look, or I can just send this directly. And if I click send, then I have the ability to send, for example, by email. And I could send the results of this as a visualization. That'll actually send a PNG file that contains a version of this visualization. I could send a CSV file, which contains the output of this data table, or I could even send it as an Excel spreadsheet or render it as a web page. So you do have the ability from within Looker, the Looker interface, to share these results. Now, there was also a question around PDF. So if this were saved as what's called a look or saved to a dashboard, let's go in and let's just save this particular visualization to a dashboard. And let's save it to a new dashboard. And let's just call this performance month to date. And obviously, I would likely have a few more tiles on this dashboard, but let's just follow along with this particular example. So I'm going to load my performance month to date dashboard, which will take just a moment. And we see we've got this tile here, right? So you can envision that there might be a few other tiles that we might have here. I can, of course, resize this if I were to edit it. So let's just, whoops, clicked on the wrong thing there. Let me go back. So I'm going to go ahead and edit this. We've got everything that we need right here, but we're going to change the name of the tile. So instead of new tile, we'll call this versus best month ever. And we'll hit save. And now that I have this, what I can do is there's the option to download as a PDF, download as an embedded series of CSVs. And if I was in a development mode, I'd be able to send this via those same channels you saw before, email, Slack, etc., and be able to render it as a PDF. But if I chose download as PDF, then I could render this as a PDF. Looker will actually generate the PDF for me. And what you'll see is in just a moment, oops, we ran into a problem because I'm still in development mode. So once I push this into formal production, I would actually be able to create a PDF from this. But currently, because I'm in, this is still a sample set of data and I have not made this production ready, I'm not able to show you the rendering of it, but the option is absolutely there.
Okay. Well,
so hopefully that answers the question.
And we have plenty more questions, and we're actually coming up to the top of the hour, so maybe we'll take just one or two more. So we have a question here. Was the code written in Python? Also, how would you identify the top 10% of the customers and their profiles, such as their home location? So I guess who's using Looker?
Got it. Okay, so I'll answer the first question when you say when I'm not quite sure what the question around the code is. So let me answer the second question, and you can always add some clarification into the question around the question about the code specifically. So in terms of how we would identify the top 10% of customers, I'm going to assume that you're asking sort of top 10 by some characteristic, right? So what we can do is let's go back to this, this users fax table that we created, right? So I did create this lifetime order rank. And what I might like to know is, well, how does this lifetime order rank, sort of compare to the total count of users that I have? So one way that I might sort this out is that I can look at ID and I can look at lifetime orders, and I could potentially add additional, not lifetime orders, but lifetime, let's go sales rank. And let's add in some demographic information about them, such as their city and their state and their zip code. And we'll run this query, right? And what this will give us is a set of all of our users. I'm actually going to then sort this by lifetime sales rank. And of course, what we're interested in, whoops, we cleared out my results. Let me rerun this. And we've got all these users, of course, that don't have a sales rank because they don't have any sales. So we'll further filter this, and we'll say that, well, we want their sales rank to not be null. Right, now what we've returned is sort of all of these results. We've hit our row limit. So that's important to note. I could expand this row limit, but what we're going to do is calculate a total. And I now have an opportunity to compare this rank, right, to my total my total count of customers, right? So if we want to look at users that are in the top 10%, what I could do is create a calculated field that takes my total count of all users and takes my lifetime sales rank and actually divides it by that count of all users. Right. So while I haven't created an overall custom measure for this, right? I could do something like create a table calculation for our count of users, and actually let me go ahead and add that back in. And so we should come up with a total here for our users count. And now what I can see is that I've got 69,630 users, right? So if I wanted to, I could take my lifetime sales rank, divide it by my total count of users, and I could decide whether I wanted to include customers that have never purchased or not. But I could either do this as a custom field, or I could actually define this field in LookML. We can just do it quickly as a custom field. Let's just call it lifetime sales rank, and let's divide that by total users count. And we'll just call this percentile rank, and we'll calculate this as a 1 decimal place percentage value. Right, now, I would be able to further take a look at, well, what users have a percentile rank of 10% or less. So in the interest of time, it would take a little bit longer to go through the actual process of converting this into a field overall. But what I can share with you super quickly is that it should be easy enough for us to, in the same way that we built this lifetime sales rank, lifetime sales, lifetime order rank, we could actually add a window function that itself calculated using a window function a percentile rank, and many SQL dialects automatically have that, and then that we would be able to filter on that lifetime sales rank. So that'll pause. Maybe if we have time for one more question, otherwise we'll go ahead and wrap up.
We're actually right at the top of the hour, so
Okay.
I think we are out of time, unfortunately. Anyone who asked a question that we didn't get to, we will make sure you get a follow-up via email. So I'd like to thank you so much for your presentation. And I'd also like to thank our sponsor, Looker, and everyone in our Spiceworks Ziff Davis community for joining us today for our special web event, Scaling Our Growth Using Data Analytics. Just a reminder, if you missed any part of this event or just want to watch it again or share it with a colleague, you will receive a link via email over the next few days. I am Karen Bannon, and on behalf of Scott Barber, Looker, and everyone at the Spiceworks Ziff Davis family, thank you for your time and have a great day.